Today I want to introduce to you how we find the equation of a cubic function. Remember what we used to do when finding the equation of a quadratic function. Just go through your notes, you recall that. Now if we are finding the equation of a cubic function, the equation in general must be y is equal to a into x minus x1, x into x minus x2, x into x minus x3. So there are three brackets. Remember, for the quadratic we did not have this, we only had that. Now we are introducing this because it's a cubic function. So normally it's done either with the sketch or without the sketch. If the x-intercepts are given, we use this relationship. It's only used when the x-intercepts are given. Let's look at an example. Number 1. F of x is equal to ax cubed plus bx squared plus cx plus a d. Passes through these points. If you look at the given points, minus 3, 0, it means it's on the x-axis. Minus 1, 0 is on the x-axis. 0 minus 3 is on the y-axis. 4 and 0 is on the x-axis. So we have got 1, 2, 3 x cut and only 1 y cut. The question then goes on to say, determine the values of a, b, c, and d. To do that, as I said originally, we are going to use y is equal to a into x minus x1 into x minus x2 into x minus x3. So we write that, but substituting our 3, because there was a minus, minus it becomes a plus, minus, minus it becomes a plus, then minus it becomes minus 4. So when you substitute the point minus 6, 0, it means x is 0. On the right hand side, x is 0. This is 0, 0, 0. So we shall have 3 times 1 times minus 4, which gives us a minus 12a on the right hand side equal to minus 6, which then gives us a is half. We then expand. I'm not teaching you how to expand, but if you expand, you end up with half x cubed minus 13 over 2x minus a 6, which implies that our a is half, our b is 0, our c is minus 13 over 2, and our d is minus 6. We are moving on to example number 2, and it is saying, consider the function f of x, defined as we have already said in example 1, but conditions are given here. f1 is equal to f4. Right? We are saying when we substitute our f1, it is exactly the same as f4. Very, very important for us to understand here. Then we are saying here, our f3 is actually 8. Then f dash of 1 is equal to f dash of 3 and is 0. These are suggesting to me that this is the stationary points, because we use f dash of x to get the x values at the stationary points. Then it says, draw a sketch graph of f and indicate the x-intercepts and the turning points. Then part B, determine the values of a, b, c, and d. Now, using the knowledge that we already have, we are told from the question that f1 is equal to f4 and y3 is equal to 8 and f dash of 1 is equal to f dash of 3. So what do we have? We notice that our f dash of 1 is right here. So it means at 1 there is a turning point, and at 3 there is a turning point. This is what we have been given here. At 1 there is a turning point, at 3 there is a turning point, and that is why we have the turning points at 1 and at 3. Now from there, what else do we need? We need now to talk about the other x cut. It is f1 is equal to f4. So you will notice that here is our 4 and our 1. They can only be equal if they are both at y is equal to 0. So we have identified our turning points. We also identified our x cuts, and then we drew our graph. But however, that can be confirmed when you now answer part B. Part B is saying determine the values of A, B, C, and D. So with the information that we have 0, 1 is a turning point. We have seen that already, and it's on the x, which means it's repeated. That's what we agreed last time. So it means our y is equal to, we substitute, our x is 1, so we have x minus 1, and the other x is a 4, so it's x minus 4. But we are also given this condition, f of 3 is equal to 8. We substitute for y, our 8, then 3 is substituted in these 3 brackets, and we end up with that, which when solved, we end up with a is equal to minus 2. We substitute our minus 2 and we expand. We end up now saying our a is minus 2, our b is 12, our c is minus 18, and our d is 8. Which means this point, I can only put it now when I have d is equal to 8. I can place it there. Now, question number 3. F is a cubic function. Consider the sketch of the derivative of f. Remember, the derivative of f gives us a quadratic function. Because it's a cubic function, its derivative gives us a quadratic function. So that is why we have a parabola here. Very, very important. Given by f dash of x is equal to ax squared plus bx plus ac. This is our f dash of x. Now the question says, write down the coordinate of x, write down the x coordinates of the stationary point of f. Then part B, classify each stationary point and justify your answer. Then part C, determine the x coordinate of the point of inflection of f. D, then draw a sketch graph of f. That is what we are going to answer now. Now, I want you to understand what we are given here. What we are given here is the first derivative of a cubic function. Now, this is actually showing us the gradient of the cubic function. This here is the gradient of the cubic function, where you can actually tell us that at this point the gradient is 0. And at that point, the gradient is 0, because this is gradient. Although it is a quadratic function, it is actually defining the gradient of a cubic function. That is why it is f dash of x. So this here is the gradient. So at this point, the gradient is 0. And at this point, the gradient is 0. Therefore, x is equal to 2 and x is equal to 4, because the gradient at the turning point is always 0. Thank you very much. Part B, classify each stationary point and justify your answers. We have said at this point is a stationary point because it's a turning point, because its gradient is 0. And at this point is also a turning point, but we don't know what kind of a turning point it is. So what do we use? The second derivative test. So the second derivative test is just deriving this one for the second time, which means we are saying f dash dash of x. And what is our x? 2. But however, we are using the graph. We are not doing any calculations. We are using the graph. At this point, f dash dash is a tangent at that point and is tilting where? To the left. So it is a negative gradient. That is why we are saying here f dash dash of 2 is less than 0. Graph is concave down. We have a local maximum point. And again, at that, if we place a tangent at that point, which is the gradient of the quadratic function, which is f dash of x, it is tilting to the right. Therefore, we have a positive gradient. So f dash dash of at point 4 is greater 0. Graph is concave up at x equal to 4. So we have a local minimum. Then part C is saying determine the x coordinate of the point of inflection of f. Whenever we have the x coordinate at the turning point and another x coordinate at the turning point, what do? We just find the midpoint of these two. How do we do that? Midpoint theorem, we add the 2 and divide by what? By 2. So it's that plus that, which gives us 6. 6 divided by 2, we get 6. We get 3. So that is why our x is equal to 3. Please get to understand that the point of inflection is always at the equidistant of the turning points. Please understand that. Then last for today, then draw a sketch graph of f. We have said at point 2 there is a maximum turning point. That is why we have a maximum turning point. At point 4 we have a minimum turning point, and this is the sketch of the graph of f. We don't know the x cut, so we don't write anything. All we know, it has a maximum at this point and a minimum at this point. At 4 minimum, at 2 maximum. I think for today we end there. Thank you very much.